Hello everyone. In this video, I'm going to review some of the concepts we had learned previously on the topic of subsets. And then I'm going to work through some examples, go through some exercises to reinforce those concepts. And then at the end, I'm going to show you a technique of creating all possible subsets from a given set. Now I'm going to begin with a brief overview of what subsets are. Subsets are smaller sized or equally sized sets created from the elements of another set. So I'm going to illustrate that with an example. So I have a set here containing 4 elements A, B, C, D, and I'm going to create subsets from this set. Now a subset can have fewer values than in the set, but its values must also belong to the set from which it is getting created. So A, B, C, the set containing A, B, C is a valid subset of the set A, B, C, D because all its elements are also a part of the bigger set. Likewise, let's create another subset A, D. It has only 2 elements, but both A and D are also members of the original set. So it's a proper subset. Now, another thing is that the set itself is also its own subset. So when we create our list of subsets, we have to remember to list the set itself belonging to the list of subsets. All right, so A, B, C, D is also its own subset, and the null set is also a subset of any set for that matter. All right, so we have to remember to list the null set as a subset of whatever set we are working with. Right, now the notation to denote sets or subsets looks like this. It is a right facing U with a line beneath it. All right, so this is the notation or the symbol which reads as is a subset of. So to express a subset, this is how we put it together. Just pick any subset. In this case, I'm going to just say use A and D, the subset which has A and D, and then the symbol to denote subset, and then to its right, I'm going to write out the set from which the subset was created. All right, so in this case, it's A, B, C, D, A, B, C, D. All right, so this reads as AD, the set AD is a subset of the set ABCD. Another terminology that we should be familiar with is a proper subset. Now, proper subset will contain all the subsets of a set except the set itself. Remember, I said that the set itself is a subset of its own. All right, so in a proper subset, however, we will have to exclude the set itself. All subsets would be included except the set itself. And that's what makes it a proper subset. The symbol to denote a proper subset is just a right facing U. It doesn't have the line underneath it that represents a subset. All right, so that's the difference in the symbol, in the notation between a subset and a proper subset. Now, the number of distinct subsets that can be created from a set, number of distinct subsets that can be created from the set or from any set is given by the formula 2 to the power n, where n denotes or n represents the number of elements in the original set. So in our set here, there were 4 elements. So the number of distinct subsets that can be created out of this set of 4 elements we can use this formula. 2 to the power n would be replaced by 4. So 2 to the power 4 is 16. So we can expect 16 distinct subsets created out of a set with 4 elements. As far as proper subsets are concerned, remember, proper subset excludes the set itself from its list of subsets. So it's going to be 1 less than the number of subsets. So formula for that is going to be 2 to the power n minus 1. So that would be 2 to the power 4 minus 1, which would be a 50. All right. So with that understanding, let's go on to working on some example problems. Now, in this set of exercises, we are expected to read through each of these statements and decide whether they are true or false. And if they are false, we have to give a reason. All right. So let's look at the first statement. It says here that the set containing circle, this notation says, is a subset of the set square, circle, and triangle. All right. So the statement is essentially saying that the set containing circle is a subset of square, circle, triangle. Now think about the property of a subset. In order for something to be a subset, it must have elements from a given set. All right. So the subset has the value circle, has an element circle. So does the set. Therefore, this is a true statement. Correct? It's a true statement because the subset has an element which also belongs to the set. Likewise, the next one says this subset containing rain is a subset of the set which contains rain, snow, sleet, and hail. Again, this is a true statement because the subset has an element which is also a member of the set that it is a subset of. The next one is potato, carrot. So the subset has elements which are potatoes and carrots, and the set has elements carrot, squash, cucumber, and celery. So we see over here in the subset, there's carrot in both the subset and the set. However, potato is not a member of the set that the subset comes from. All right. Therefore, this is a false statement. All right. This would be marked as a false statement because by the property of subsets, by the definition of subset, the elements in a subset must belong to the set from which it was created. Since potato is not a member of the set, of the bigger set, it's not a subset of that particular set. The next one, the subset has elements book and magazine, and the set from which it is created has book, newspaper, journal. So book is there in the subset and the set. However, magazine is not there. Therefore, this is also a false statement. Correct? It's not a subset. All right? It's not a subset of the set containing book, newspaper, and journal. Then we have a set containing cheesecake and pie. But look at the symbol here. This symbol reads as is a proper subset. Is a proper subset. So a proper subset is or will contain all the subsets except the set itself. Correct? By definition. So the subset here has cheesecake and pie. So it is a valid subset. It's not the entire set itself. However, let's check if the elements in the subset also belong to the set. So it has a cheesecake and the set also has a cheesecake. It has pie and so does the original set. Therefore, yes, this is a true statement. All right, it is a proper subset. Likewise, the next one has, in the subset, it has elm, oak, and pine. And in the set, it has oak, pine, elm, and maple. So this looks good. It is a proper subset. And the subset is not the set itself. Therefore, it is a true statement. It's a true statement. Look at the next one. It has a subset which contains elements gold, silver, and bronze. Is a proper subset of the set gold, bronze, and silver. This is a false statement because the subset is the same as the set, correct? It is the same as the set. It is a subset, but it is not a proper subset, correct? By the definition of a proper subset, the set cannot be in the list of subsets, correct? So that's why this is a false statement. The next one is 8, 9, 10, 11, and then it's asking, is it a proper subset of the set 9, 10, 11, 8? So even though the order of the elements are not the same, the elements are essentially the same. And because the symbol here is for that of a proper subset, it's false, correct? Because the set and the subset are the same. They are valid if we are just talking about subsets, but because this is the symbol, and let me just erase this. This is the symbol for a proper subset. That is the reason we have to say it's false, because the set and the subset cannot be the same. Now I'll do one more here, which says spade. And then we have this symbol, which is not a symbol for either subset or proper subset. This is a symbol which denotes, is a member of or belongs to a set, all right? Is an element of. However, look at the statement. The way spade is surrounded by curly brackets tells us that this is a set with an element of spade in it, all right? And this symbol says is an element of. Is an element of what? Of the set diamond, heart, spade, and club. This is a false statement because this is a set. Spade on the left-hand side, it is a set. A set cannot be an element of another set unless the set itself contains sets. It's a set of sets. That can happen as well. All right, but the way this is presented, the set spade has to be compared to individual elements of this particular set. All right, so that's what makes it false. All right, so I think we've gone through enough of these examples to test our understanding of the concepts of subsets as well as interpreting their notations, right? Now in this part, I'm going to show you how to come up with all possible subsets that can be created from a set. So I have a set here, a set of 4 elements with the elements R, S, T, and U, and I'm going to create all possible subsets that we can come up with from this set. All right. Now, before we start, we know we can find out how many subsets we should expect, how many distinct subsets we should expect. And that comes from the formula 2 to the power n, n being the number of elements in the set. So that's 4. So 2 to the power 4 is a 16. So we should expect 16 distinct subsets once we are done with the process. All right. So for the first one, remember that the set is also a subset of itself, correct? So just write the set as is, and that's going to be the first subset, which is going to contain all the elements of the set we are working with. All right. Now the next set of subsets would be subsets with 3 elements in them. And for that, I'm going to use what I called is the tree method. All right. So remember, it's going to be 3 elements, subsets with 3 elements in them. So just take the first element, and I'm going to work it out here. I write the first element R, and then I have to go 3 times from R. So after R, what comes next? S, T, and U. So I'm going to draw 3 branches from R and write here R, S, T, and U. Now because I want 3 elements, I have to go once again. So after S comes T, right? So I'm going to put a T as the branch from S and another branch from S where I'm going to write the U. So after S, we can either get a T or a U. So that's what I'm going to write. And then over here, if we have R for the first one, T for the next one, what comes after the T? I'm going to get a U. So I'm going to write the U next to this branch. All right. So R, T, U is another combination. And there's nothing after U. So this falls off the tree. I'm going to cross it out. All right. So now I'm going to traverse the tree and write out these combinations, but we are still not done with combinations of 3 elements. All right. But we have to continue. But before that, let me just write these combinations down. So for number 2, I have RST. So I'm going to write RST. And then for number 3, I have RSU. So essentially, you're just walking the tree and picking up all the letters as you go. So RSU and then RTU, right? That's the 4th one. RTU. All right. So we have to do a different tree. So we have captured all combinations of 3 starting with R. Now we will work on another one starting with S. So there's going to be another tree starting with S. So this time I'm going to write S. What comes after S? We can either get a T or a U, correct? And then what comes after T? After T comes U, so I'm going to write a U. And there's nothing after U, so this falls off the tree. And we pick the combination STU. So I'm going to write here as the 5th one, it's STU. All right. And we have completed all combinations of size 3. All the subsets that can be created of size 3. All right. So now we start with combinations of size 2 and we follow the same process. All right. So again, it's going to be, you're going to work again, create a tree. So from R, you can get either S or a T or a U, correct? Now, you don't need to go another time because this time we only need combinations of size 2. So I'm going to just list this RS, RT, RU as my 6th, 7th, and 8th combination. All right, so 6th is RS, 7th is RT, and 8th is RU, right? So now we start again combinations of 2 starting with S. So I'm going to again create another tree here. So, but starting with S, I've already captured everything that can be created starting with R of size 2. So from S, I can either get a T or a U, correct? So I'm going to write here the 9th one. I'm going to go to the next column. The 9th one is going to be ST, a subset consisting of ST. Then number 10 is going to be SU. SU, And then we have TU, that's another one of size 2. So T, and after T comes U, there's only one. So let's list that. TU, and that completes all combinations of size 2. So now the next one is combinations of size 1, and for that you don't need to work through a tree. Just write all the individual elements. So R, a set containing one element, so just list them. R, and then S, 14 is T, and 15 is U, correct? What about the last one, 16th one? We need 16 distinct subsets because we know that's the number of subsets that should come up from a set of 4 elements. So recall that we said that the null set is also a subset of any set. So the last one we will just write at an empty set, all right, with just 2 parentheses, nothing between them. All right, so this is how you can go about creating distinct subsets from a particular set. All right, this will ensure that you got all the different combinations that one can come up with as subsets of a set. All right.